Right, lesson 315, the last lesson of unit 3. It is rates of change and polar functions. So we've talked about rates of change throughout the school year from unit 1 all the way now to unit 3. Would not be right as much time as we spent on AROC to ignore it here. Hey, Marcus. So as we get started today, that's what we're looking at. To find, if you remember, rate of change is basically going to describe over a interval if the graph is increasing, decreasing. We'll also look at extrema today. What does extrema mean? Maximums and minimums. We'll look at the distance from the pole and average rates of change, like I said, of r with respect to theta. So let's get started. Example 1 here. It says consider the curve r equals f of theta. Now, normally, let me pause here. Throughout unit 1 and unit 2, you saw me write y equals f of x over and over and over. And as we learned on lesson 313, that's because this is rectangular. What are the two types of variables in rectangular? X and y. And so those would be in terms of x and y. What this is just saying here, if I haven't explained that yet, is this is just changing my variables in here to r and theta. This is a polar form. This is polar. My variables here are now r and theta. But it says the polar function is 5 sine theta on the interval 0 to 2 pi. And it's shown right here. So the first question that we're going to talk about is what is the maximum distance from the pole? Now the pole means the origin. So I want you to look on this graph. What is the maximum that this circle ever achieves away from the origin, the pole? That's right here. What's the furthest distance this circle ever seems to travel away? 5. It's up here at 5. This is the point right there. That's the maximum point. The answer here is 5. And also say 5 units. We don't know what we're measuring in. It's the maximum distance is 5 units. And so a question can be asked, where does this extrema occur? And it really wants to know the theta. Okay, so the way I want to write this in, this is the r value here. The way they would show this is they would actually say in the absolute value of r, that means the maximum distance. It could be positive, it could be negative. In polar, we don't really care. We just say what's the farthest away. So I'll go ahead and include that in. That's what that means. That maximum distance is 5 units. And so we would say like this, when you write where does it occur, you'd say the absolute value of r equals 5 when theta equals, and now we have to figure out what that is. Now, y'all probably know by now, if we are straight up, I want you to think about the angle. What measure of theta would straight up be? What angle is that? I heard Kalia whisper it. I have more people around the room. What theta would this be to turn my axis, to rotate my polar axis to this point here? Okay, I'm starting to hear more people whisper it. Go ahead and just say it out loud. Where does that happen? Pi over 2. That happens when theta is pi over 2. That's where that occurs. Now, that's not the only time this occurs. So, what is the other angle that could also produce that value of here 5 units up? What else could produce that? Any takers on what it could be? It's 3 pi over 2. Yeah, if you rotate all the way around, 3 pi over 2 would generate the value -5. Whoops, I don't know what I just did there. If you went to 3 pi over 2, that would also generate the same thing. So I'm going to go ahead and put this back. I don't know what I'm doing with that, so I'll go here. So my second value, the absolute value of r equals 5 at pi over 2 and 3 pi over 2. Now, truth be told, at 3 pi over 2, it was a -5 because that would be going 5 units away from 3 pi over 2. But nevertheless, since it's the absolute value, what does the absolute value do to a negative? That's right. So if you want to list that as a note, just so you know, r equals -5 when theta equals 3 pi over 2. But because they're going to say the absolute value of r, that you ignore the negative. We don't care about that. We'll say that a maximum occurs at 3 pi over 2 as well, even though it's technically a minimum. Okay, here's a different question. What values of theta does f of theta equal 0? Now, just make sure you look up here. F of theta itself, what is f of theta equal to right here? What variable? R. So this is saying r equals 0. That's what it's saying. So I'll translate this for us here. R equals 0 when? Let's find out. When does r equal 0? Well, how about right now? Am I intersecting the circle at 0? Yeah. Now, what's my theta right now? No, my theta. My theta is like the angle. 0? Okay, and what if we went all the way around? It would be 2 pi, not 2 pi, sorry. Before we go like to this point. Goodness, come on. My axis is not cooperating with me today. What if I got to here? So where my positive end is now on the left. That's pi. So it could happen at 0, it could happen at pi. Okay, and now if I went all the way around, 2 pi. So 0, pi, and 2 pi. Those would be the 3 times you would say when theta equals 0, pi, and 2 pi. We are looking on the interval from 0 to 2 pi, so yeah, you would include all 3 of those. Okay, so now it said to describe the behavior as theta approaches this maximum from left and right. Okay, so as we approach pi over 2, what's happening to my value? Where are we starting at 0? What's my r value here? It's written right there. What's my r value when I start with my theta at 0? 0. So what's happening at first as I start to rotate this? Is my graph increasing or decreasing? As I start at 0 to get to 5, what would my graph be doing? Increasing or decreasing? Just look at the axis. So here's your plus symbol. I'm starting at 0, but as I'm going around the circle, it's moving up this axis. So is this increasing or decreasing as we approach pi over 2? It's increasing. Do you see how the circle's intersecting and it's just moving up this axis? It's moving further and further up the axis. So it's just increasing up our axis. Therefore, what we'd say on this is we would say that the function is increasing from, I forget what the symbol is for theta, so let me just pull up my little keyboard here, and if it ever shows up. Okay, now I got my little keyboard thing up. The function's increasing from starting at 0 as theta increases from 0 to pi over 2. We were increasing. Okay, so now what happens after increasing to 5? What does the graph start to do after increasing from 5? I'm going to spin my axis again. What does this graph start to do? It starts decreasing until we get to 0. And actually, this next time as I go around, guess what it continues to do? It continues to decrease all the way, and this would be -5. You see how the positive's on this side now? It would decrease all the way to there. Now, what angle am I now at? If the plus is at the bottom end of my page, you can't see it. Let me put it down here. What angle is straight down? Pi over 2. So we decrease, the function decreases from pi over 2. Whoops, hit the wrong button again. Okay, it decreases from pi over 2 to 3 pi over 2. And then finally, it would increase one more time. After 3 pi over 2, this graph would start to increase again, and it would increase until 2 pi. So to finish this off, the function is increasing from 0, from when theta is between 0 and pi over 2, and then And it continues to increase from 3 pi over 2 back to 2 pi. 3 pi over 2 to 2 pi. And so what we're going to talk about today are those type of things. The maximums. So those are the things we're going to talk about today. We're going to talk about where are the maximums located. And we won't care if they're a maximum or a minimum. We'll talk about when do we have zeros. By the way, in the maximums, what was the name in the unit 1, unit 2 that we called maximums? It started with an E. Extrema. These are the extremas. We'll talk about where the extremas occur. Oh, there's the word right there. We're going to talk about zeros, and we're going to talk about increasing, decreasing behavior, and we'll use all that to find average rate of change, okay? So as I go on to part D now, here's what I want to do now is I want to graph this function. So right now on this function here, what's the midline? What's the number that's all by itself in this function? That's not 5. That 5 is the amplitude. The value that's attached to the sine or cosine, that is your amplitude. That's how high and low your wave will go from the midline. What's the midline then? 0. Good. Our midline is 0. If it doesn't show one, the midline is 0. So as we go to graph this, let's go ahead and use your ID badge and put on a horizontal dashed line to represent your midline at 0. That's that value right there. That's y equals 0. That's the midline. Now, for the functions for sine, as we graph this, I'm just going to give myself a little circle to use to help me explain what I'm going to do here. Sine, I want you to think on a unit circle. Does sine is what variable again? Sine is the y variable. So I'm going to put a little y-axis here for a moment to help me find my value. Sine is y. When we begin over here, does sine begin at its midline, minimum, or maximum? Midline. It's midline. So it's going to begin at the midline, which basically the midline of the y-axis is 0. So it's going to be this number 5, the amplitude, times 0. What is 5 times 0? 0. Okay. Then, so let's go ahead and put that dot on there. Then as we come up to this point, what is this point in terms of pi's? If this is 0, how many pi's is this point? Pi over 2. I want to get our 5 critical points on our graph. At pi over 2, what happens is sine at its minimum, maximum, or its midline when you're at the top of the circle. Maximum. Sine and cosine's maximum is 1, so put a 1 there. What's 5 times 1? 5. So at pi over 2, let's graph it up at 5. 1, 2, 3, 4, 5. Okay, we come around to this angle right here. How many pi's does it take to get to the left side of the circle? 1 pi. At 1 pi, is the y value, the sine, going to be at its minimum, its maximum, or its midline? Is it going to be at its middle value? This is the y-axis here. Is it going to be at its middle value, its maximum value, or its minimum value? Middle. So it'll be the amplitude times the middle value of 0. What's 5 times 0? 0. Okay, so at pi, we'll be back to 0, the midline. Now we come to this point here. This is 3 pi over 2. At 3 pi over 2, it'll be 5 times. Now this is the y-axis minimum. What is sine's minimum? -1. So it'll be 5 times -1. What is 5 times -1? -5. Good. So it'll be -5 there. At 3 pi over 2, it's -5. Good morning. And so we finish off now. As we go all the way around, not only is this 0, it's also 2 pi. At 2 pi, we have a value of 0. Let's connect those dots. And let's see how this compares to what we just said a second ago. If you remember on the previous slide, on part A, we said the maximum R value was 5. What does it appear the maximum value is of this graph? 5. Now on polar graphs, the maximums and the minimums will appear the same typically. And so we said that it happens at two different places. Do you remember where we said it occurred at? Just look across. Pi over 2 and 3 pi over 2. Does it match up with this graph? Do we have our extrema at 5 pi over 2 and at pi over 2 and 3 pi over 2? Yeah, and on part B, we said r equals 0 at three locations, 0, pi, and 2 pi. Do we have zeros at 0, pi, and 2 pi? Absolutely do. And then finally on part C, we said the function increases from 0 to pi over 2 and 3 pi over 2 to 2 pi. Does this function increase from 0 to pi over 2? Does it increase from 3 pi over 2 to 2 pi? And what's it do in between? Decrease. So we did all of our parts correctly. So I'm just showing you how I'm comparing the two, polar and rectangular again. Now let's move into part E. It says this, consider the value of the radius for the curve. Is there an interval where the radius is negative? Was there a value when the radius was negative? We want to know, is there a value where the radius, the r value, is there any values of theta where it's negative? So I'll give you an axis so you can think about it. Right now, what's the value of the radius? If this circle intersects our axis at the pole, it's 0. Okay, what happens as I start to rotate this? It's increasing. This is the positive side. It's increasing, 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 increasing. Okay, now it starts to decrease, and we come back here, and now what's it at? 0. Okay, now as I start to get to these angles in the third quadrant, where does it intersect the circle? Is it intersecting the circle on the positive side? This is the positive side here. Or is it intersecting the circle at the negative side? Negative. So we start having negative values from pi all the way around. All the way around. This is where the angles we're looking at right now. They'd be the fourth quadrant. We would be negative values all the way around until we got to 2 pi. So from pi to 2 pi, we have negative values. So is there an interval where the radius is negative? Yes. The answer is yes. The symbols for radius to be negative is r is less than 0. When do we start becoming negative values? Do you remember what I said? Starting from pi, and you would not include it, so you just do less than theta, which is less than, and when do we stop? 2 pi, that's right. So let's summarize all the things we found here. From 0 to pi over 2, and if it helps you, cheat and look at this graph. From 0 to pi over 2, is our graph positive or negative? It's positive. Go ahead and fill that in here. Our graph is positive from 0 to pi over 2. How about from pi over 2 to pi? From pi over 2 to pi, is the graph positive or negative? It's positive. Now, some people are going to say negative, but they're not thinking about positive, negative means the y values. Are these values above 0 or below 0? Above. It is positive from pi over 2 to pi. It is positive. What about from pi to 3 pi over 2? Negative. And what about from 3 pi over 2 to 2 pi? Not positive, but negative. It's going to be a different vocabulary word on that part. So we'll get to that. So these two are both negative and negative. Let me move that out of the way a little bit more. Okay, so now this blue line represents different thetas as I rotate it. However, oh, come on. Okay. The values that it's intersecting are the r values, but where it's twisted to are the thetas. So the thetas rotate it. The r would be however long it is where it intersects the circle. So right now, the point where it's rotating on is 0. This would be a positive number because if our theta was in the first quadrant. So think of our thetas going around on the outside. So first quadrant would be like pi over 6, pi over 4, pi over 3, then pi over 2. Then you get to the second quadrant, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. Third quadrant, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2 is over here. Does that make sense? So as I'm rotating it, that's the thetas. The r value is where it's intersecting. So right now it's positive because it's towards the angle. Towards the angle, towards the angle. These would all be positive values because the intersection is close. From the pole, it's going towards the angle. Does that make sense? To get a negative, it's when after you pass pi, now I'm thinking about third quadrant angles down here. So now as I'm at a third quadrant, it's intersecting the circle on this side of the pole, way over there. Okay, so does that explain to you what the line represents? You got it now? All right, good question there. That's what the blue line represents. Okay, coming back down. Is the R value increasing or decreasing? This time, increasing means it's moving upward. Decreasing means it's moving downward. Tell me, what's happening on my first interval? Increasing. What about my second interval? Decrease. What about my third interval? Decrease. And my fourth interval? Increase. So it's increase, decrease, decrease, increase. Increase. Decrease. Decrease. Increase. Actually, I should put the ing. That's how they wrote them in. Okay. Finally, the last question that on polar is a little bit trickier. And that is the distance from the pole, that means the distance from the x-axis, is it increasing or decreasing? This would be the absolute value of r. Is my distance from the x-axis increasing or decreasing on this interval? It's increasing. What about here? Is my distance from the x-axis increasing or decreasing? Decrease. So I increase, decrease. Now, is my distance increasing or decreasing from the x-axis here? Not decreasing. The graph is decreasing, but is my distance from the x-axis increasing or decreasing? Do you see how it's getting farther and farther away from the x-axis? This will have r, the absolute value of r, increasing. And now finally, this last section, I know the graph is increasing. I'm not asking that. I'm saying, is the distance from the graph to the x-axis increasing or decreasing on this interval? Decrease. So it'll be increase, decrease, increase, decrease. But I'm going to throw in an extra symbol here, just so it's clear to everybody, is I'm going to say this time the absolute value of r is increasing. I'm throwing in that symbol. The absolute value of r is decreasing. The absolute value of r is increasing. And then the absolute value of r is decreasing. Okay, so that means the distance from the pole, or you could say the distance from the x-axis. Now, that's example one. I'm going to walk through you with this. I'm going to walk through this with you today 4 times. That's our goal. At this time, I want you to stop. Let's see what you learned this first time around, and then we'll try example 2 and see what we can get there. So DOL number 5.